Hi, in this video, we're going to talk about how to implement merge sort. So we just saw the pseudocode for merge sort. The actual Python code sticks pretty close to the pseudocode, and I already typed it out here. So let me explain it kind of like line by line here. Um, so first of all is the kind of the method signature. Now merge sort takes an iterable or a list, right, as the input to sort. Now, because we know we're going to call it recursively and with a smaller sublist, so that means we don't necessarily just sort the entire iterable every single time. So we might need to know where those sublists start and where it ends. So that's why there are these extra parameters here. Now, but at the same time, because merge sort can be called by the client code, and the client code really doesn't want to, specify, or we don't want the client code to specify the star at the end, right? When the client code calls, we are sorting the entire list. So if that's why there's the default values for the start and end. And when the start and presumably end is none, then we know we have to sort the entire list. And when we sort the entire list, the start would be index 0, and the end would be the length of the list. And remember, end is almost always exclusive, so the actual last index would be end minus 1. So moving on, again, for the merge function, I've defined it as a nested function inside merge sort. And the reason I do that is just because merge only makes sense in the context of merge sort. So I don't want to kind of make merge available in the global namespace or global scope. So that's why I do a nested inside merge sort itself. Another thing to know is that since we are merging two sublists of the iterable, so we need the start and end for the first sublist, and the start one and end one, and then the start and end for the second sublist we're merging. Now the detail will, oh well, actually, so one more thing, and that is because as we just saw that when we merge two sublists together, and it's actually very hard, well, I wouldn't say very, but it's kind of hard to merge those lists in place. We got that means we are placing new values into the list that we are reading from. So that's often kind of hard. So to kind of avoid that problem, we will our for merge the function, it will return a new list with the two sublists merged instead of merging the list in place. So what that means is when we call merge and when we get the result back, that we'll have to update the original list uh, with the merged result. And because again, all of our sorting functions, they sort in place. So, and that's why we do this kind of using the list slice. We're updating part of the list with the return result of merge. So now let's look at how merge sort actually works. We already know what the base case is, right? When the length is either 0 or 1, then it's already sorted, so there's nothing to do, so we just simply return. Now, in order to split the list into half, we calculate the midpoint. So, star plus the length divided by 2. That would be the index of the midpoint. Um, and then the first half of the iterable would be from start to the midpoint, and then the second half would be from midpoint to the end. And we call merge sort on the first half and then a merge sort on the second half. Right? And once those two halves are done, then we merge them. And here is the start and end index, right? Again, the first half, it starts at start and ends at mid, and the second half, it starts at the middle and ends at the end. Okay, now that we know how merge sort works, let's look inside the merge function. So as I just mentioned, the output is going to be a new list. So that's why we initialize a empty list. And then if you remember when we kind of went through our demo, that we maintain 2 pointers, and we just use the parameters as these 2 pointers. That star 1 would be pointing to the first unsorted element in the first list, and then star 2 would be pointing to the first unsorted element in the second sublist. So, and then we just iterate through both of the lists until we reach the end of one of them. And in each of the paths, we just compare the two unsorted elements from each of the list. And if the element from list 1 is the smaller one, then we append it to the merged output, and then we advance the reference in the first list. Otherwise, we append the element from the second list and we advance the index of the second list. Now, once we reach the end of one of the lists, all we have to do is append the remaining elements from the other list. And we can very simply actually do this kind of blindly for both lists. One of them is going to be empty, but that would mean that the star index and end index of that list would be just equal to each other. So we're just adding an empty list to it. So we again, no need to check for anything. This expression can handle empty lists. Okay, so that's it for the code of merge sort. Now I hope that makes sense. So if you look at how a merge sort actually works in this picture, which is courtesy of Wikipedia, you can kind of see, conceptually, it just kind of moves from the top to the bottom. And if you look at, this is the original list, it gets split into 2, and then each of these 2 lists gets split into 2 again, and then again they got split until they reach a level where each sublist is just a single element. And then at this point, we can start merging them back, right? So now we have sublists of 2 elements. Each of these sublists is sorted, and again we can merge them to get bigger list, and then merge them. Finally, we get back all the original elements into a sorted list. Now that's how it works conceptually. However, if you trace through the code, and you should, which is to help you to understand merge sort and also helps you see how exactly the recursion works, then you can kind of see that the execution of the code doesn't neatly follow this pattern. It's something that is actually slightly different. So if you want to give it a try yourself, pause it before I kind of explain the order of all the steps involved. Okay, so how the code would actually work is that, so when we first get this list, it will try to merge the first half, and then it will try to merge the first half of this list. So when we come here, and then again it will try to merge the first half of this, and that's when we get to a sublist of a single element. And then so this half is already sorted, and then it will come to the second half of this thing. So it will come here and realize this is sorted. Now this list now has two sorted sublists, so it would actually try to merge them, and then we get a merged list of two elements now, which correspond to this sublist. So this half is now merged. So we come back up here, and then we'll try to try to sort the second half of this list. So it'll come down here again, follow these steps, and then now we have merged and sorted second half of this list, and then these two now can be merged. So we are down here with a sorted and merged list of 4 elements, which means this sublist is finally merged, and this list is the first half of the original list. So now we're back up to the second merge sort of the original list, and then we'll go down here again, and then back up here, and then finally the second half is merged, and we can finally merge the two halves of the original list, and that's kind of the order. Now that you kind of have an idea of how the merge sort actually executes through and sort the small list like this, you can use the visualization tool here, either watch or step through the animation for merge sort on a larger list and make sure that it works as you would expect it to. And then you kind of know I'm going to ask you this, that now that we have a merge sort, we should test it, and you should test it. It's very simple, 2 lines of code, and I'm going to show that. Obviously you've seen that a few times by now, that in order to test the merge sort, all I have to do is this, and I can actually run it. It should run relatively quickly because merge sort is fast, and it's all correct. And the more interesting thing we want to look at is obviously how it performs. And here are, on my machine again, it's kind of slow, but anyway, on the same machine you can compare the performance number of merge sort, again shell sort and insertion sort and bubble sort, and you can kind of see that it's quite a bit faster. And I think the difference would be even more pronounced if the list we're sorting is larger. So here's a plot. The blue and the red, they are the bubble and insertion sort, and on this plot, the shell sort and the merge sort doesn't even register, just because these two are so slow. So I plot again on the log scale. So now you can kind of see that the fact that these are there are some differences, but again, that bubble and insertion sort are a lot slower than shell and particularly merge sort. Now, if you only plot shell sort against merge sort, shell sort, this is a trend. The trend line kind of it looks kind of polynomial. Well, it's kind of curved up, right? Merge sort, it all looks almost linear, not quite. It's still curved up a little bit, but it certainly doesn't grow as fast as shell sort. And as we'll see, that is because merge sort is, even in terms of big O, is faster than shell sort.